Hi folks, Mr. Long here. I'm going to do a screencast on um, shapes of how the x-intercepts of certain functions can be understood by calculus. Okay, so how do we use calculus to help us understand the shape of an x-intercept? And what I'm going to do is just look over how it would work for something like y equals x cubed. Okay, so you know from advanced functions that y equals x cubed has a very characteristic shape like so, and it is very flat at the x-intercept of 0, and then as it moves to the left and to the right it gets much steeper. So if you only knew calculus and you didn't know that from memory of what it looked like, how could you use calculus to understand the shape of that x-intercept? Well, let's look at how we might do it. So y is x cubed, that means y prime is 3x squared. So let's just make a little table for 3x squared and see what happens to the slope. So I'm going to pick, let's see, I'm going to pick a point at -1, at negative 0 0.0 or 0.1, at 0, at 0.1, and at 1, and see what the slope is. Okay, so I'm substituting those numbers in to the derivative. So we're just going to do this without a calculator. So I've got -1 squared. That's +1 times by 3 is 3. Then I've got negative 0.1 squared. If I square negative 0.1, it's the same as squaring 0.1. It's 0.01. So that means that's 0.03 because it's 3 times 0.01. If I sub 0 in there, 0 squared is 0. Okay. If I sub 0.1 in, that's going to be the same as negative 0.01, so 0.03. And then if I sub in 1, it's going to be 3 times 1 squared, which is 3. So remember that this is the tangent slope. Okay, it's the tangent slope. So if I was to look at this, that means it's, moderately steep. 0.03 still positive, but it's just a little bit steep. That's horizontal. That's a little bit positive in terms of slope, and this is getting more positive. So if we look at that, it looks like this. It goes like, oops, can't see that, can you? So it goes like so, then it goes less, then it goes horizontal, then it goes 0.03 positive again in terms of slope, and then it goes like that. Is that the shape of the curve for y equals x cubed? Yeah, I'm pretty sure it is, right? I'm pretty sure it is. That is the slope of y equals x cubed. So we can do that, folks. If we take the derivative, it describes the slope of the original function, right? So when we don't know the shape of an x-intercept, we can use the derivative to help us, okay? All right, so here we go. Okay, here we go. So, so what we're going to do is move on over here. And so that's a bit of prior knowledge there. Now we need to do another little bit of prior knowledge, graphing reciprocal functions from grade 11 and advanced functions. Okay, so what does the graph of 1 over x look like? Well, the graph of 1 over x, let's just sub some numbers in. Let's do 1 divided by x, where x is negative 0.01. How many times does 0.01 go into 1? So 0.01 will go into 1 100 times, and then it's negative. 0 goes into 1. Well, it can't, right? It's an infinite number of times. You can put 0 into 1 an infinite number of times. And then 0.01 goes into 1, again, 100 times. So what does our graph look like? Or what does our table look like? Well, that's going to be negative 100. That's DNE, does not exist, and that's positive 100. So if that's 0, this is way down here at negative 100. The other graph is way up here at positive 100 when we're at positive 0.01. And then when x gets really, really big, what's 1 over a million? Well, it's really close to 0. Okay, so there's what 1 over x looks like. Now, here's where I'm going to change things up a bit. What if we want to get the graph of 1 over root x? Well, can I put negatives in here? Am I allowed to have negatives in there? A negative for a root? Nope, I can't do that. So look at this. This one here is dne. This one here is dne because I can't divide by 0. And now if I replace x with 0.01, so think about that for a second, folks, whether it's a square root or not. If I've got 1 divided by a really small number, what is that answer to that? What's 1 divided by a really small number? Well, a really small number goes into 1 many, many times. So all I'm going to write there, instead of doing the calculations, I'm just going to say a big positive, like with a big plus sign around it. And then, by the way, what would happen if x got really, really big, like a million or a billion? 1 divided by the square root of a billion is going to be pretty close to 0. So look at this. Here's what this graph looks like. Notice it looks almost exactly the same as 1 over x, except it only exists to the right of the y-axis, right? Because you can't have negatives under a root sign. Let's go to an even funkier one. Whoops, this one here. Okay, this one here. I really like this one. Now we're going to do 1 divided by the cube root of x squared. By the way, can I take cube roots of negatives? What's a cube root of negative 8? Let's just double check. The cube root of negative 8, 3 numbers that multiply together to give me negative 8. That's negative 2 times negative 2 times negative 2. So it is negative 2, okay? So cube root of negative 8 is negative 2. So that's fine. We can do cube roots of negatives. But let's think about this for a second. So we're going to do the graph of 1 over the cube root of x squared. Okay, so let's do this. So I'm going to start with negative 0.01. So if I take negative 0.01, by the way, you should be writing this down so you have a nice set of notes. 0.01 squared, what is that? 0.01 squared is a really small number, okay? Is it positive or negative? Well, if I square it, it's positive. Then I take the cube root of that, it's still a small number. So what's 1 divided by a small positive? A big positive. A really big positive, right? Again, the squaring turns the negative into a positive. Squaring 0.01 is 0.01 times 0.01, which is 0.0001. That's a really small number, and even the cube root of that is still a small number, right? So then it's 1 divided by a really small number. Well, a really small number goes into 1 many, 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 many times. Okay, am I allowed to divide by 0? No, does not exist. And then, what about if I sub in 0.01? Well, I'm squaring it, which is going to make it even smaller, because 0.01 times 0.1 is 0.01, right? And so 0.01 times 0.01 is significantly a really small number. Cube root of that is still pretty small. And then I've got a small number in the bottom going into 1. That's going to be a really big positive number. So we know that it's asymptotic because I can't divide by 0 here, but it's really high positive on the negative side, right? And a really high positive on the positive side. And then it goes like that. Okay, as x gets to be really big, like 1 divided by a billion, is going to be a really, a billion squared square cube root, right? A billion squared cube root. So it looks like that. All right, so that's how you can look at exponents and know what graphs look like. It has a lot to do with whether or not you can square root or cube root negatives. Okay, so those are some basic graphs of reciprocal functions. So that's all the prior knowledge. Well, you know what you could do? I think as a good thing to do, you could try this. So try sketching this. Try sketching y equals 1 over the cube root of x. We'll do that as 1. And then number 2, why don't you try sketching y equals 1 over the 4th root of x cubed. Okay, the 4th root of x cubed. So what you should do right now is pause it and then try to do those graphs. Okay, pause it and try to do those graphs. Oh, what answer should you have gotten on this? You should have gotten your graph here, 1 over the cube root of x, should look like that. Why is it? Well, again, think about this. When x is 0, clearly 1 divided by 0 is not possible. That's why you get a vertical asymptote at 0, at x equals 0. Then cube root. Can you cube root a negative? Yes. So that means 1 divided by a really small negative is a really, really big negative. Then on the right side, if I have a really small positive, 1 divided by a really small positive is a really big positive. So 1 over cube root of x looks just like 1 over x. Let's go over to this one. 1 over, and by the way, what would this be in exponents? It would be 1 over x to the 3 over 4. So let's see here. So I'm going to put a 0 in. So I put 0 in for x. It's 1 over 0. Okay, that's fine. It's a vertical asymptote. Then I'm going to put a small negative in. Can I cube a small negative? Yeah, and it's going to get a lot smaller. So think of negative 0.1 times negative 0.1 times negative 0.1. So once I've cubed that negative, it gets really, really small. Can I take the 4th root of a negative? No. No, you can't take the 4th root of a square root, a 4th root, a 6th root, an 8th root. You can't do it with any even root. So the function doesn't exist over here. Okay, it doesn't exist. However, it does exist on the right side because those are positives. Okay, so there you go, folks. That's what those two look like. Hopefully you did that, and now you have that prior knowledge background that you need to go ahead and do your investigation for the next part of this lesson.